Hi, thank you everybody for joining. See a good list of attendees out there. And today's conversation is all about the right tools for the job as related to data science. We'll get into some introductions in a moment, but initially, just to give you an idea of what we're covering, again, it's more about tooling as it relates to data science. We're going to talk a lot about the life cycle. We have a scenario just to keep in mind that we've worked on. And the scenario is basically training a model that'll predict attributes from an unknown fingerprint. So for example, whether you're in a data center or in a field, like this model might help down select possible suspects given an unknown fingerprint and trying to get an identification earlier than later. The demo covers a lot of topics. We're less focused on the model, although we'll dive into it. It's not the world's greatest model, but I think the surrounding infrastructure, the things that we've done here, the best practices that we're going to be talking to are hopefully going to be very helpful. It's a lot of conversations that Corey and I have in our day jobs as solutions architects at Red Hat, and it uses, I think, the best of everything. So, Corey, you want to introduce yourself?
Yeah, thanks, David. So a little background on me. I've been in IT for a long time, and I'll talk about the major stops I've had. I've been in high performance computing, cybersecurity, and then various infrastructure roles, and then most recently in data science and helping to make all that experience a practical use to data science groups. So that's what I've been doing recently, and specifically working with David Marcus in using Kubernetes tools with data science.
Thanks, Corey. I am David Marcus, and I've been at Red Hat for, well, since 2019. Before that, I was a contractor, so it's a defense contractor and a contractor for space systems, specifically like the Orion vehicle and several human spaceflight missions. Being at Red Hat, I've had the opportunity to work in a lot of different spaces, and really excited with what Corey and I and my team deal with, which is all data science related, whether it's in a public cloud or whether it's at this cutting point of the edge, as like small as we can get things, and everything in between, and then how data science fits or can be optimized across that whole set of destinations along the way and back. So without further ado, we will go ahead and get started. Just to give you an idea, please go ahead and push your questions in the chat. Corey and I are going to do our best to kind of field these. It's going to be very much of an open format. We're an open source company, and we kind of take the same application to our webinars as well. So we'll be both talking to these slides along the way, and we have a live demo, so please stay tuned. When we're talking the right tools for the job, I think Corey and I have both seen a lot of great tooling that's out there, great platforms. A lot of times it's very specific, and I definitely dealt with this previously in my career, where you get kind of locked into a solution, and a lot of times, especially in scientific domains, you don't want to get restricted by your tooling. So I think we've seen a lot of tools that benefit the training side of the house. So if you look at the left side of this diagram and those blocks that somewhat represent like a typical life cycle, engineering data, experimentation and prototyping, training models, optimizing models, and then getting those artifacts saved off. Those tools are going to be different, right? I might use different tools to tackle the same problem to see what fails differently. I most likely, even on the second pass, may try some different things as well. I don't want to fix my solution to my tools. I also, at the same time, don't want to bring my development environment into production. I want to keep that as pristine as possible, where my lab side on the left might be really messy. The process is going to be pretty iterative from what we always see. You get it out the first time and you're almost wrong every time, or at least not where you want to be. And so you bring it right back through all the steps and phases that you need.
I also want to introduce sort of the hats that we're going to wear. So the invisible hats. So David and I are going to talk to personas within the work that we did. David was mainly operating as a data scientist. Like he's training those models, he's working with those tools that he was talking about. And my main role was either as an enterprise architect or a solution architect, and also as an ML engineer or data engineer. So those were some roles that, these are hats that you're gonna sort of see pop up invisibly over us as we present this. Also, this slide is super boring and it's intentionally that way. This normally would look like a NASCAR, like just plastered with logos, but we intentionally did that because we want to talk about the patterns and not specific tools. We will probably still drop some tools in here.
We have a NASCAR slide at the end.
Yeah, there you go.
No, that's great.
Introducing sort of the personas you're going to hear from us.
No, that's good, because that is one thing is we do see a lot of, or we're asked a lot to do more than what our role or focus is. So as data scientists, a lot of times we get the model, we're usually the ones that know the input signals that need to come into it, the output prediction that's supposed to happen. And then at the same time, it's like, okay, now bring this thing to production. Or, I might be asking for infrastructure and tooling, and IT has a lot of jobs that they have to deliver for, and to get my stuff available to me and enable like GPUs for accelerated training, it's just not easy. So I'm asking them to do more. That usually turns into me wanting to get it done faster. So I'm going to go ahead and take on a lot of those tasks. May not be applying best practices, but I'm getting it to work so I can start my development, start my training, experimentation. Like, a lot of this takes time. Most of the time is usually focused in just data and accessing that data. But at the end of the day, what I'd really like to focus on are those top 3 blocks. Like, let me get my feature engineering and my data analysis. Let me get some experimentation. Let me get training cycles down, optimization. Let me build some pipelines, and let me just get my artifact saved. If I could stop there and not have to manage the stack that I'm running on, or have to worry about how I might get this thing out into production and allow the business to seek some value from it, that would be ideal for me. Like, I would love to stay in that space and give me whatever tools that I want for the job.
That's a good segue to boundaries. So talking about logical and skill boundaries. So we're gonna lead into that a little bit here. So some of these boxes talk or are representing boundaries around skills, or where there's handoffs or systems. Maybe there's a boundary with systems or tools as well. So specifically here, we're looking. Do we want to just dig in to start talking about, I guess, some of the whys? So one of the whys that we get asked a lot is why I use Kubernetes for data science. Why should I use this highly complex system and have to train data scientists to use it? So let's answer that. One of the reasons is it's not as complex as you think. It's actually, Kubernetes is there to help abstract some of the complexity that happens on the back end. So as a data scientist, you don't want to have to learn how to do operations for a database. Like, if I want a Postgres database, I just shouldn't have to learn all the nuances of virtual machines or containers or all those infrastructure elements. Heaven forbid you learn networking. So like, Kubernetes is there to help abstract that and make it easy. It's shared resources. So I dare you to try and do anything on your laptop that you can do in Kubernetes. Try and run that 24/7. Try and scale it, and try and have automation. It does give you autonomy, but so does Kubernetes. And we'll try to demonstrate that and show that as we go through this. Also, reproducibility and consistency. So Kubernetes helps to orchestrate that, so that we're doing data science, but there is also science to the infrastructure. We call that DevOps. Being able to reproduce that infrastructure in a consistent way and quickly, that is science, but it's in infrastructure. So some of these terms, we're doing the same thing, different roles, different jobs. Hopefully this makes more sense as you hear us talk about it.
Yeah. So I think a lot of the things that you're saying are helping overcome some of with the tasks that we had for building this model, is how we overcome some of the problems that we were often plagued with. And that might be, each of us having to manually schedule resource usage for training cycles. And I've done it as simply as like we had a sign up sheet, right? Or a shared Excel doc when we were getting super advanced, but we're not pooling those resources and optimizing the consumption of that. You mentioned 24/7. Yeah, a lot of times my training is going to take time, and I don't want it to stop and have to kick it back over and either pick it up back where I left off or just restart the whole thing. As well as like just the reproducibility and the consistency. So you talked about containers in that light from a science perspective. Like, yeah, I want the results that I'm getting on my end to be something that you can replicate on your end. That is the idea of this science, right? No matter where I'm running it, to a degree, it needs to have the same or very similar results and expectations.
Two things I think I want to speak to here is one is data. So talking about data real quickly. So one of the things when we're talking about tools, I'm going to use the term data gravity. What that means is the more data that you accumulate in a single area starts to create gravity of tools or usage. So for example, if you have a data lake inside a data center in a large enterprise, you want to bring the tools to the data. That gravity is going to pull things closer to the data. Whereas if you don't have any data and you're just starting in the cloud, maybe you have IoT and you're pulling it all into a cloud resource, that's going to start creating gravity and your tools are going to gravitate toward that. The second thing I wanted to also focus on, go ahead and can you advance the slides? Are we good? So building on what David was saying about containers. So as one of the first fundamental things about containers is it's easy to distribute that application or the data science, like the parts that make it valuable, that actually allow others to consume what you've done, the work you've done in data science, is easy to distribute in a container. As you get closer to the edge or something that's less of a data center, it's a lot easier to package it up that way. That's what sort of this slide's representing, is you can embed that model in a container, and the further away from that centralized infrastructure, the consistency you get and the ease of distribution comes from a container. When you decouple that, there's more complexity. So let's say you store your models in S3 and serve them out somewhere else and query them. You have a failure point at that, and it's also a little more complex. It's good in development, but maybe not in serving and production. So easy to distribute. That's the first one with containers.
Yeah, and I think there's a lot of times there's this game of like tug of war between data science and app dev or software engineering or ML engineering, whatever role, fits this balance or responsibility of like, again, I'm tackling the left side for the data science piece, and then now to get that artifact into the real world and allow it to start interacting with the real world. There's usually more around that. There's some kind of interface or stream or batch process or job, or there's different ways to get these models served out to production, and a lot of times that's the sticking point. Like that's where these models start collecting dust as we try to figure out how to implement them.
So Dave just said the 4-letter word production. I'm going to totally call you on that. So production is one of those things that everybody says, but nobody knows what it means. It's like when you break up with someone and you say, let's just be friends. That's production. Nobody knows. And so production, what we've heard, what we think the reality is production is sharing what the work you've done with others. That's really production, like at a basic term. So I'm able to share my model and let others consume it. That is a basic definition of production in most cases.
Yeah, no, it's perfectly said. Yeah, like in my opinion, like once that model's interacting with the real world outside of the lab, outside of my control, like now we've hit production. That's perfect. Yeah, I'm happy you said that. And that's scary, right? That takes a lot of trust. There's a lot of process around that. And what we've seen is like there's really two good ways to get things out, and then understanding like how this model is going to be used or where it's going to go. In this case, this fingerprint model might be one that fingerprint images are sent back to the data center, or just like looking at, this data lake and running batches across everything and trying to do different matches or attribute predictions. This also might be sent out to like agents devices in the field, and now you have a different strategy for how to get that model out there. We will be demonstrating both of those today. But that's how you get into what we consider like an embedded model, where you're actually taking the model, the inference engine, everything's getting encapsulated in this container, and then it can be put to a registry and sent anywhere. And then you have the other option, which is saving the model into a data store, having an inference engine running, and it's just kind of polling. It has a path to that model, and it calls it at request time, and it's a lot easier to update. It's less cumbersome. Two different ways, coupled versus decoupled. Both of them kind of branch off into other strategies, like serverless would kind of follow probably the independent model a lot easier than the server, the containerized one would. Go ahead, Corey.
Yeah, no, just to tie up also some of the things around a container. So one of the reasons you're probably either heard about it or talked about using containers for data science is also, like David was alluding to, is the consistency, encapsulating all of that stuff. In addition, there's security, which is something data science rarely ever worries about, at least from my experience. So security that's included with containers is process isolation. It also allows you to put limits on resources. So if someone exploits a container, like something that's really popular is crypto mining, let's say that someone exploits your container and starts crypto mining, they're not going to get very far because you've already constrained it inside of the limits that you would have there. The other one is efficiency. It's very efficient. You don't ship a giant like blob of stuff. It's usually very efficient when you're sending a container image. You're reusing a lot of the same things over and over. So those are some of the reasons why you would use containers. We sort of just went into talking about that, but these are some of the benefits. And
yeah, and like the distribution of it, just like you said, I want to be able to share the science that I'm coming up with. I want somebody else to be able to do it, see if they can get the right results, see something that I didn't, make changes to it, and then send it back to me, and not having to do a bunch of stand up in order to provide that. The encapsulation, if I'm running it in AWS or if I'm running it on premise on some, server in a closet, I want it to run the same way. I don't want to have this different dependency management that I have to deal with. The security side, I'm a data scientist. I don't think about security. It stifles innovation. But the efficiency side is definitely another one. Like I want this thing to be as lean and mean as possible. I want to strip away anything that's not important to it, which has these other benefits of, like Corey was mentioning, from exposure to just resource utilization and optimizing that performance. I'm gonna go ahead and go to the next slide. We have one more slide after this and we jump into demo time, so please bear with us. Please put in questions if you have any at this time.
so
And this one is, go ahead.
no, I was going to say this is the infrastructure side. This is the boring stuff. Like data science shouldn't care about this stuff except in concept, and that's what we want to cover here. So that's where someone like me comes in, and I'm helping to capture those elements. So as David's working on developing that model, generally in this case, the Jupyter notebook, and was working on training, and then I was observing what artifacts he was leaving behind with that. Was there code? Was there a notebook? All those things that were artifacts. And also I was polling him for what did he need? Like, what do you want a black background in your Jupyter notebook? Because I can do that. Do you want it to spin down, or do you want to spend 50 grand in GPUs in the cloud? Like, what things can I help you do to make it easier so that you're not worried about it? So that's what this slide sort of speaks to, is some of the automation. So you're going to see some key things here like Git. So a lot of the stuff that we're doing, everything that we did was pushed to a Git repo. Even if it was a little sloppy at first, we made sure that we captured those elements and that then polished them up later. David, I'm sure, loves it. I always bugged him and I was like, have you Git pushed today? Like, did we lose any work? Because our cluster disappeared a few times.
Many times. I think towards the end of it, I was asking you if you get pushed.
Yeah,
I know I did that once.
Yeah. So we both kept each other honest, and that's the thing. Like, we wanted to make sure we captured our work, and so that was one of the tools that was central to that was using Git. Also, you're going to see YAML. Like, data scientists, you're not going to love YAML, but it keeps that consistency. That's the science part for the infrastructure. Some of the tooling. Go ahead.
No, I was just going to say, in how I see this is, like earlier in this talk, we mentioned about, if I'm asked to start my work and I'm waiting on the spin up of my infrastructure and the tooling that I need and the enablement of accelerators, I'm just going to go spin up my own stuff. And that's going to create this silo of operations that happen on my side. And that's going to push my artifacts into this like inaccessible place that, the rest of the organization has a hard time, utilizing, and definitely maintain, creating any automation around to pull in. So one of the nice pieces here is, especially with, open source tooling, is there are ways to optimize integration and to ease that lift. There's definitely ways to kind of circle around a common platform that I can use from my perspective and have a start and stop point that Corey can also use, and that we're not asked too much to do what's outside of our scope, but at the same time kind of circle around something that's very collaborative. Like we're all working off the same baseline, the same common architecture. And by doing that, we're at least, I might have a silo, but at least that silo is on the same platform. It's on, I'm ending up in a shared object store that the rest of the company also has access to, and keeping that dust from getting too high on my models.
One of the ways I think we maintain consistency was also a very iterative approach, and iterative in the sense that it's actually a little bit nerve-wracking because it was destructive. We destroyed our environment in order to make sure we didn't forget something.
Yeah.
So with this demo, we probably destroyed it probably, I don't know, how many times do you think, David?
15 more. It got to the point where we kind of enjoyed destroying it, so we could lean on automation to spin it back up and start, with as little tweaking as possible, and just go right into the science or right into the application.
So I think part of I think people are nervous to do that, but if you're doing automation correctly and you're capturing those elements, it's a very good thing. It feels really good when you go to sleep at night and not worry about, is it going to work tomorrow? One of the icons on here is, as well as that circle, it's the flash symbol. We're not sponsoring DC here, but that's an operator. So operators, what they do is they abstract complexity into, and so what they're an application that captures intelligence around some kind of thing, like for example, a database. As a data scientist, you don't want to worry about managing a database, and so an operator would do that for you. It would maintain the life cycle of that. So in Kubernetes, that's one of the benefits of Kubernetes, is operators do work that you don't want to do, and it's intelligent. Generally, it's only as good as it's designed, but that's the purpose of them.
Yeah, I think what we see is a lot of operators being contributed by community or by other providers, basically wanting their software to work on the cluster. I think we all have some of our favorite operators. Corey, I think you have one, which is I think it's Crunchy, right?
Yeah, I think if we have time, I'll show that in the demo part. But yeah, like Crunchy's a Postgres database. Again, I'm trying to stay away from the logos on the NASCAR, but yeah, it allows you to say, I want a database, I want this much storage for it, and I want it to run highly available. If that's all you have to do, if you just put that in code or a declarative way, the operator goes and makes that happen. So you don't worry about it as a data scientist. You don't need to learn DNS. You don't need to learn networking. You don't need to read the manual on Postgres. It's 4 lines of code for you and 100 lines of code for operations.
Yeah, so at the end of this one, really what we wanted to do is focus on, our roles doing our respective jobs. We don't want data science managing infrastructure and minimize them writing apps, or minimize us writing apps. I'm very terrible at it, as a matter of fact. We don't want apps rebuilding predict functions that data science has, or trying to sift through and grab out the important pieces that they think, and possibly risk sending in incorrect signals or formats. We want this to be something as collaborative as possible, but still respectful of the roles. We want to maintain velocity, and we want to lean on the automation of these platforms. It's there, we may just have to uncover it or figure out who can tackle that part the best. So again, really just getting down to allowing all the roles to stay focused through integration. So for this fingerprint model, what we end up landing on, and this is our NASCAR slide, is we did lean on AWS for this one. It was something that we could spin up pretty dynamically, and the goal of this was really getting a model out into production from start to finish. We utilize SageMaker tooling, so although we work for Red Hat, we are solution architects, which means we like the right tool for the job, and the right tool for this job was leaning on SageMaker tooling. So we'll talk through what we used and why and how we used it. We definitely leaned on object storage. This data we started with came from Kaggle. It is a Kaggle competition. It's one that fit our use case the best and allowed us to kind of demonstrate some of the complexities of the surrounding parts. So again, not the greatest model in the world, but we had fun with it. So I'll definitely talk through starting with data, going into my notebooks, explaining what I did, run on EC2 instances and the elastic nature of that. Ultimately, my goal is save a model in object store that allows Corey to pick it up and run.
And so, yeah, that's what's visualized here is some of those boundaries. So logically, like David was mainly working in SageMaker because of this use case. And then his handoff to me was, okay, a trained model that I could take and then either containerize and serve out. And so I was working sort of in that black box. We wouldn't be Red Hat if we didn't say OpenShift once. So that's where we're at. That's where I was operating. And then overall, we're using a cloud provider to serve all that out.
Yeah, and we've had great challenges for this. If you have challenges, we do see some of the questions in the chat, so I have not forgotten about those. Keep them coming, and we'll either address them live or in the chat. But part of it's like, well, why not just use AWS services and SageMaker to just kind of continue on to the right of this life cycle and getting it into serving? For us personally, that got into like we wanted to use SageMaker for their model building tools. Like they're very robust. There's a lot of automation to take advantage of there. But we also wanted this model to be something that could be run anywhere. Containerizing that model worked out great for us, and then being able to run it not only on our platform, which is OpenShift, but even further out to much smaller Linux-based systems as you kind of walk out to the edge. The same model basically running whether in unlimited cloud resources or to the end. The reverse is also true. Like you could also do all the same stuff on Red Hat OpenShift, which you've also have the same demo working for, which is we have our own data science tooling and ecosystem. You could just walk to the left with that. And again, it becomes very dynamic as far as like what slider are you going to use for where your data is at? Is all your data in the cloud? Great. You can lean on a pattern like this. Do you want those models to walk out to the edge? Excellent. There's a common hybrid architecture that allows you, or a common hybrid platform that allows you to do that. Is everything on premise, air gap disconnected behind cipher locked doors? I used to live there for a while. Yeah, I'm going to need different tooling, and I might stretch the OpenShift product ecosystem out for that. So for this one, we had this perfect blend, this better together story. Got to work with AWS SageMaker team on this one. Obviously, we had the Red Hat experience, but this wasn't just a Red Hat solution, and that's really important because, again, we're getting back to if you restrict my tooling and my options, then you're restricting my solution and the efficiency there. So we'll dive into the demo. Corey, you want to close that out with anything?
Yeah, I was just going to have two things. So one is we don't think about this very much, but data science. I challenge you to find any tool that you're using today where you haven't touched open source. Like everything you use is based in open source solutions. I guarantee you, like even if it's a proprietary tool, if you pull the panel off underneath, there's something that's open source based. So always remember that. I think open source has become a commodity in data science, so that it's one of those things like we don't think about when we push the light switch, like turn the lights on. The same thing, we don't think about open source when we use it in data science, but it's everywhere, and we don't realize it. That's the one thing. The other thing is, do we want to grab some of these questions? I just learned how to use the tool.
Yeah, I'm looking at the questions right now. I think some of these are great to answer live. We're doing pretty good on time.
Okay.
Right at the bottom of the hour. So yeah, let's spend a couple of minutes, and then we'll also do the same thing at the end as well. Okay. So one of the questions that we see was, how do you calculate the average cost of using these tools? I've avoided adopting the cloud because it's not clear to me, how it's really going to cost. To be perfectly blunt, because we can be, there's an excessive cost when it comes to moving your data. So if your data is already in the cloud, like it's already there, you're probably avoiding, your cost is already kind of has interest there or gravity there. If your data is coming from different sources or different producers that might be outside the cloud, moving that data into the cloud can be very expensive. Then you add on this cost of now serving models and exposing services. All of that starts to tick up. We have had some interesting conversations around this cost balance. It's actually why you see the choice of tooling here was to be very cost aware. And in this kind of use case, this was one that we wanted to be able to serve the model from cloud services as well as bring it on premise. And how do we do that in the most consistent way possible without having to rewrite code? I don't know if I answered that question exactly, Corey. Maybe you heard something else.
Yeah, I can just add a little bit to that. So always, like, this goes back to use the right tool for the job. So if you already have resources at your availability, use them. One example where I can think of, like, yeah, I hope no cloud providers hate me after this, but GPUs, you're paying, you might as well buy a GPU card and use it than use it in the cloud, because within a day you've paid for it, like, or something. It's very a short period of time, like a week. So make sure, like, if you don't have resources, the cloud is very useful. If you do have IT resources, try to use them. And the people that are doing this analysis need to not be thinking that the cloud is a panacea. It is expensive. It's someone else's computer and you're paying for it. So how do you calculate the cost? It's always going to be more expensive in the cloud, like, if I just make a general statement. So be careful with that. You can think a greater than symbol in most cases.
You'll probably see some of the costs associated with this one. I personally like the training and the acceleration I had in the cloud, spin up what I needed, do my training, tear it down, and then completely delete it. And it was very elastic to me. But that, again, that's for my training side. For the serving side, it's going to be more persistent, more long, more of an uptime. Let's jump to the next one. If you looked at CPU utilization via the top, what percentage of Kubernetes typically required? Do processes running under Kubernetes appear as separate processes or bundled under Kubernetes? I think, Corey, that's all you, man.
Yeah, I can talk to that. So that's sort of an infrastructure question. So yeah, because everything's a container is an isolated process. Container images contain all the dependencies. So you can look at some of the overhead. There is an overhead with Kubernetes. Generally, once you're going at scale, when you're operating by yourself, a container is probably good enough. But when you start to work as a group and that grows, Kubernetes will have an overhead, but it's generally minimal. Where that grows, where that overhead grows, is the more operators you bring onto the platform, the more automation you want to build into it. That's where you see that overhead. And they're all isolated. So every process, and I can speak to OpenShift specifically, everything is built as a container. So everything that maintains the platform runs inside a container, which is an isolated process.
Yep. You just saw me spinning up the notebook in the background. It's actually because we have a lifecycle script that was going to turn it down moments away. So I didn't want to have to deal with that. Let's see the live demo. I saw the question. It is a live demo. We're about to get right into it. So please bear with us and thank you for being patient. Integration of MLOps with existing DevOps practices in the organization, anything to watch out for? Yes, excellent question. We deal with this one a lot. Sometimes there's this misconception of, like, is MLOps overtaking my DevOps practices? Likely you have existing software, existing software pipelines that are working, right? And they're supporting production. Like, don't change that. As you identify, like, introducing, model predictions into these pipelines, like, MLOps is going to intersect with it, right? It's going to join into that. There's different ways to get data science artifacts into those pipelines. Sometimes we'll see if, like, data science is owning their pipeline start to finish to get models saved off. I might be leaning on Python-based tools. If I'm leaning on someone like Corey, he might use something like an Argo or a Tecton base, just based on the skill set differences usually in languages. But again, it is going to intersect and consume these artifacts into a DevOps pipeline. MLOps being just a different pipeline, DataOps having another pipeline. So I would say that's the one thing to watch out for. You're going to have an intersection. It's not going to be like one pipeline, Lord of the Rings, one ring to rule it all. I think we'll jump into demo right after this, Corey, but did you want to follow that one up?
No, I think that's good.
Okay. So let me jump into, so again, what we were talking about from that last graphic was, I was starting with data. We are sidestepping some data engineering that's happening. We cheated it a little bit intentionally. And part of that was because the reason why we built this demo, and then there's a lot of conversations to have around data engineering and labeling. When I say we cheated it, again, that data I'm intentionally starting from is fingerprint data that's in a bucket. It's basically a huge list of fingerprints that exist we do have it already labeled in the file names. Again, we did use the data from Kaggle. It's an existing competition that again, really allowed us to demonstrate the rest of this pipeline. But like under the training side, for example, we went and grouped these images by left and right human attribute as far as like left and right hand that a fingerprint's coming from. So if I look at a fingerprint, can I tell that it's a left or right hand? Not very good. Can I tell that it's, what sex the person is that left that fingerprint? Also not very good. Can I tell which finger that fingerprint's likely from with a confidence? Also not very good. We picked one here. We can demonstrate all of them, but this one is just basically grouping all of my left-hand fingerprints from my training data are grouped in left, all right are grouped in right, and I'm going to infer those labels from that structure. There are other labeling conversations. We're more than happy to have them. AWS has theirs from like labeling jobs and Mechanical Turk. In the OpenShift ecosystem, we'll see things like Label Studio, which is really powerful. Again, it's really the right tool for the job, and the right tool for this job were these. But we do find we spend most of our time in the data cleaning and curation. If I go back to S3, so now you saw at least where my data is at, it's in a bucket, has a path to it. We're also not showing Studio and Studio Lab. Those are very rich experiences from SageMaker, really great. We were doing this because we were designing it for like a GovCloud solution. So we wanted to be like the most restricted environment possible, because as you open the doors, like the tooling gets richer, the experience gets richer, but we wanted to start, as lean as possible. So what you'll see like in a GovCloud setting on AWS is very typical to this and what you'll see on the left-hand side. So we talked about labeling, like ground truth with labeling jobs. Again, I did sidestep that. I did use labeling jobs, but nothing to demonstrate. I obviously use Notebook for my IDE, and the nice part about these notebooks are something that Corey mentioned, which is like I left a notebook running for a couple of days and ended up ticking up like $1,500 in cost when it should have turned down because it was an idle notebook. So the notebook experience from my perspective in SageMaker is great because as a data scientist, I can come in, I can pick the instance type that I feel that I need. I usually want something with accelerators. If I have the option, I'm grabbing the biggest, but maybe I don't need it. The other pieces here is like, I can identify some of the different platforms I'm dealing with or execution environments. I can integrate directly with Git. I can also append or insert my lifecycle configuration. So there's some really great canned lifecycle configurations from AWS that they have. It's like, if your notebook's idle for 60 minutes, turn it off. Start doing this installs. This way, everybody starts with the same notebook that runs this lifecycle script, like pip installs, for example, that we often find ourselves doing in the very beginning until we kind of land on a good set. But overall, like that was at least the benefit here. If you keep going down, really what we stop at is right after training. We stop because we want to be able to take the model artifact and serve it out using other OpenShift tooling. So I'm not going to spend a lot of time here in the notebook. If you've all seen a notebook, you've seen it. I will call out certain things that we did here that are kind of, I think, unique in as far as seeing it all in one spot. We do find like moving out of the notebook and into just Python functions is the likely maturity step that's going to happen here, but this is always the best spot to jump in the pool with. So we do data preparation in this notebook, probably like you would see anything. So this notebook is interacting with the S3 bucket. We look at the data set, understand like this is what our data looks like. We also do some augmentation in here, so building a more robust data set for us based on what we had for training. The funny story here is that there's all kinds of fun things you can do with augmentation to build more robust data. One of them I wouldn't recommend is flipping left and right fingerprints, because you end up with right is left and left is right. And it totally confuses the model, which is kind of funny. So we took that part out and we just dealt with rotation here. We also did some performance strategies for this, not knowing like what kind of environment whoever I send this notebook to is going to be running on. We do things like pre-fetching the data and caching that data for training in batches. So this way we can optimize that training process, kind of like whatever hardware they might be, working on. We also have different training strategies. So again, maybe I have just a single device. Maybe I run this on my local laptop, for example. It's going to take a couple hours. Maybe I have one device with multiple processors. So I want to be able to split the model up across those different processors, or maybe have, like in a Kubernetes world, multiple workers or multiple processors, and I want to be able to take advantage of model splitting in that sense. That's exactly what we're executing by default with this notebook. This training takes about 15 minutes to get through that. We do model building and hyperparameter tuning all in the same step. So I think kind of like we say, like you get out of the notebook pretty quickly into Python modules and submodules and functions. You're also going to see the same thing most likely with your tuning and optimization. Like you're probably going to start doing that in the same step as far as searching. We have different strategies. There's a bunch you can pick from. We ended up with Hyperband on this one, and you can see that's at least what we're calling here. We do the fitting of the model once those parameters are kind of figured out, and then we save that model off locally. So one of the interesting things we also did is we also compressed and quantized the model using TF-Lite. We did that, and that's done in these steps right here because again, this model might be served as a REST API in cloud services, or might be sent out to local devices in the field. So pretty simple. Train the big model to get the small model. Different strategies to do that. This is a really easy one that takes like one cell to get done. We do some like ad hoc prediction in the notebook as well. So this is one where we're kind of like loading the model that we saved off from storage, because we did push this model into an S3 bucket. Kind of just grabbing a random sample of a real fingerprint that we have preloaded in that bucket as well, and then just doing a prediction off of it, whether it's a left or right print. So this one's obviously saying it's selected this image, which is a right thumb, and we run our prediction, and then it most likely belongs to the right fingerprint. If you keep executing through these cells, it just cycles a new image and then gives you the prediction output. And so like we're 70% accurate, you pretty much see 70% of these right. So this is good enough for us to start to say, okay, my data science here is ready. My models are saved to S3. If I were to go back and look at those, you'll see the models in the bucket using the saved model format from TensorFlow. And now my job as data science is done, at least for this phase. So now what you'll see here is, I would basically notify Corey like, okay, we're ready for this thing to get, to start interacting with the outside world. So Corey, I'll go ahead and hand this off to you, because this is about the time that we leave SageMaker. Again, you could continue on, but we pause here.
So if you can share out the link, so we'll just cut to the like punchline here. So share that link out. So this is for everyone in the audience. You can go to this endpoint. You're going to generate some metrics for us. If you've got fingerprints sitting on your hard drive, go ahead and submit them. I might have restarted something. Hopefully it's still working.
You did.
Okay. Live demos, nothing ever goes wrong. Especially when you change it in production. That's a good lesson there. So talking a little bit about this, I want to also speak to some of the questions in the chat. I see sort of a pattern here, and I think some of you came here you want to learn something, and so I want to try and help with that as well. We both do. I think the challenge around where to start with some of this stuff is really where I've seen the benefit. So I'll speak to two methods of learning. One is as an individual. So as an individual, it's you. Some of you may not want to have to you just want to know what you need to go read and try out. There's some good, we could probably give some resources there. Looking at other people's work, look at something that you want to do. GitHub is a really good resource for seeing what someone else has done. Medium.com is another good one. The most important, the second thing I want to share here is you really want to talk to other people. Learning is about interacting with other people and talking to an expert, grabbing one of us. I have people that contact me on LinkedIn through educational groups where they're like, hey, can you just show me how to do this? I'm like, great, yeah, 15 minutes, let's sit down. And I think that's where you're gonna learn the most with these resources. Talk to someone who's an expert in the field with Kubernetes, and they're gonna help you accelerate your learning much faster than if you try to do this by yourself. And it's just a dialogue with that person. It's something I wish I could present and be like, if I say these words, you're gonna walk away from here knowing more about Kubernetes. I don't know, but the best way you're gonna learn is by talking to someone else. a lot of these questions is just context. Same with data science. When I want to learn more data science stuff, I talk to an expert in the field. I don't read about it generally. Like, I need to talk to someone. So coming back to our demo, this is the part that is production. I can see this. You can see this if you're going to the link in the chat. Hopefully it's working. But if you, David, can you switch back to the developer view? So we'll talk about this. This is what's running in Kubernetes. So these are containers. These circles are pods or containers. And there's a few things here. There's a Gradio client. That's essentially the client that's consuming the model. That's the web interface that we shared in chat. And then there's the model serving, which is inferencing. That's Triton. We've built that. That application there pulls from S3 storage and then serves out that model through a RESTful endpoint. There's standards for that, and that's what we're using there. The other thing is Grafana. Do you want to share the Grafana link? Are you logged in?
Yes, I am logged in.
So we love data, right? And we love visualizing data. This Grafana is a great tool for this. And one of the things that Triton is delivering out is metrics. So it's showing us, how much memory. A lot of times as a data scientist, you're not a developer, right? You don't know how much memory an application's consuming or CPU or things like that. And so you don't know what the limits you need to give a container would be maybe. So this helps you to answer those questions. Also the requests, you're seeing the requests go up. That hopefully means a few of you are clicking on that link and trying it. And we're seeing that. We're seeing the use of my model. This is helping me know if my model is being used and consumed, and then what that consumption looks like. Grafana helps to visualize that through the Prometheus metrics. Let's see. I think this is I think talking to most of the points that we wanted to make. All of these tools, open source. There are like commercial versions of it if you need specific enterprise support or stuff like that. But again, this is everything you do in data science. You're breathing air, you're breathing open source.
Yep. Yeah, and I will say I was distracted trying to answer some of the great questions we have in chat. So I will I'm going to put some dots at the one I was just on, and we'll pick this up online. But from a metric standpoint, like there's different metrics that we're going to be interested in. If Corey's like the operations side of the house, he's going to be interested in metrics that in a dashboard specifically that's going to tell him of the larger system. From my perspective, like I am very interested in the inference count. I'm interested in like how many null values are being sent to my model. I'm interested in the data format and type. I want to see what's happening and what's being sent and how things are going. Like sure, I care about CPU utilization or GPU utilization depending on what this destination looks like, but again, I want to see how the outside world is interacting with this model, how that model is predicting back. NVIDIA Triton Inference Server is a great standalone solution here that allows you again to just stand up the inference engine and pull the model or containerize that model using source to image on OpenShift. And both of those, that inference engine gives you metrics that you can quickly start pulling into view. So Prometheus and Grafana are great tools here. Watching for like drift and skew and some of these prediction issues that tell you like what I need to do in my training side and data collection side to go back through version 2. A lot of times we'll see that with like the tools that we did labeling with. You might see that with like a data model that's usually going to sit right with my actual model. That's something you might see in like Label Studio or Snorkel. We'll have that like help with explainability, I guess. So as far as like customizing metrics go, like it's great to start with canned set of stuff. It's even better to have something that's very dynamic and adaptable. And like if we wanted to add panels here, we could add panels and start doing queries on, some of the other things that we could query from the model server itself. So I will go back. Let me go back to the slides just to kind of recap.
Yeah, while you're going back, I can talk to something also that I thought of. So a lot of I'm not sure where the audience is in this, as far as who's listening today, but a lot of patterns I've seen in data science is people want autonomy. They want to work on what they're familiar with. And so a lot of that drives people to work on their local laptop. They download the data, they start analyzing it in a Jupyter notebook locally. One thing, if you want to like start learning Kubernetes or learning containers, I would say containers is your starting point. If you want to learn something, start operating, run your Jupyter notebook in a container, even locally, and then graduate from there to running it in a Kubernetes solution. Jupyter Hub, there's a lot of tools out there where you use Jupyter, and it's usually running in some kind of like automated platform, generally Kubernetes. Just start to use that and become familiar with those tools. There's also VS Code. That's one that I use personally a lot, was using VS Code to develop and then running a plugin in that as a Jupyter notebook. But that was all done in Kubernetes. And that's how I became familiar with it, was just doing it.
Yeah, and that does go into the cost conversation. Like what I showed with EC2 is now I'm running my own notebook on an entire EC2 instance, at least from my perspective. If you were to slide and do more of the development directly on OpenShift, I just pulled up our Jupyter Hub instance, and this would run Jupyter in a container that Corey and I both could work out of the same project. And now that container is just running on a worker node that has available resources. So we're most likely could be running on the same worker node, or whichever one Kubernetes schedules as like the optimal place to put that.
So talking also about costs, one thing that one pattern that we did is David had a cluster and I had a cluster, but our clusters, at least mine, didn't live more than 2 hours, and it was only like 3 nodes. So the cost, I spent probably less than $40 total in a day to reproduce his whole thing and to test it in a completely new and different environment. So some of the patterns there was, reproducibility by destroying the environment and using automation to recreate it. So, and you maintain costs. That's how you can maintain costs in the cloud, is through automation. You can't leave things running in the cloud. You need to turn them off, spin them up, spin them down.
Yep. Let me see. Some of the questions we have in the chat is like they were really good. So there was the approach of MLOps integrating with DevOps within an organization. I believe we touched on that one. Data pipeline consists of a series of Python scripts, and each script will be converted into a container, and there are dependencies among them. How do you schedule container execution in order with Kubernetes? So this is like building into probably that DAG concept, or at least, like you just said, sequence of running what and how. How do you check the data after the execution? So as far as like how we see it, we've seen probably the very basic of like, you could use something like an Elira plugin with Jupyter and write multiple notebooks and then string together this pipeline of notebooks. And ultimately that whole thing will run in a container. Just like our Jupyter lab that we're showing here is running in a container. We could go ahead.
I was going to say, so this actually is more talking to, for me, like it sounds like it's talking about a pattern that we've been doing in development, in software development for a long time, which is unit testing. So if you want to make sure that your model is doing the right thing, you need to test it and you need to automate those tests. And so building those tests in, I've seen a lot of tooling like Tox, like create a Python environment and then start querying your model with the things that you want it to produce. Make sure you get the desired outcome. Like if you're going to production, whatever that looks like for you, you need to be doing unit testing, even locally as an individual, when you start developing your model. That will help you answer these questions in a way that's reproducible.
Yep. I think the other pieces, as you kind of like mature, or as you see the maturity happen within a pipeline, depending on who owns that pipeline will kind of drive what's happening. Like I've seen, like I like TFX a lot for my pipelining, being able to export that pipeline and orchestrate it with Airflow or Kubeflow, depending if that's my job, if that's what I'm be held responsible for, or again, if my job stops at model artifact saved and collaborate with SE to get it served. it all kind of depends on like what I'm also integrating with. So I think from an orchestration standpoint of, Python scripts and containers and how you do this, depending on how big the things are, yeah, you could absolutely run them in their own containers and sequence those with an orchestrator. You could do that as far as like if the pipeline can fit into a single container and run it as a pod on Kubernetes, operate it that way as well. I think it just depends on one thing we see. We all know models don't get better with age. They also typically don't get smaller until you start to break them out and refactor things. They tend to grow in complexity and size. So there is going to be a point that you're going to have to make a decision of, how do I break this thing up into, minimum viable products that can run independently or together. Don't know if we answered the question, but please put it in there or reach out to us afterwards if we didn't. Can you show the directory structure for Kubernetes? Let's say I have app A running in Kubernetes and app B. Where do they live from a file system standpoint? So Corey, I think that's one from you.
Sure. So that sounds like an infrastructure question. And where do they live? Honestly, it doesn't matter. Like I hate to not answer that question, but that's the beauty of it, is you don't need to worry about that. When you're dealing with Kubernetes, you do a persistent volume claim. So you say, I want storage. Kubernetes says, here's storage. You don't care what file system it's on, where it lives, or anything. Like, it's just there. So like, I hate to not answer the question. Like, it depends. If it's a cloud provider, it's probably whatever they're serving out. If it's, whatever storage solution they have, that's what you're getting from Kubernetes. But it's automated. You don't have to worry about it. So yep. That was the not answering question answer. Sorry.
Yeah, no, that's great. The sharing resources, I will have some at the end of the slide deck, so please check those. There's a ton out there. Personally, I love getting into Kaggle. I also like Coursera. You'll find any of the platforms that you just asked about on either of those. AWS has their own. Red Hat, we have our own as well. Personally, I gotta go to Coursera and Kaggle and start playing around, especially from a learning perspective. It's a great community. Do you have any recommended frameworks or libraries for unit testing? This entirely depends usually on the problem. I would definitely say a lot of times we don't see testing happening, and definitely testing that's automated. So the fact that you're asking this question is incredible, so thank you for that. But it does usually depend on the task at hand. And again, I'm not answering that question, but I know we're at the top of the hour. So we'll close it out. This was our fingerprint demo that we went through and executed. We did show one method of serving it. We do have a GitHub repository tied to this. They're in the slides here below. If you want to create this on your own environment, you want to reach out to us to help kind of run through something similar, have discussions at any Zoom level, chapter level, or page level of this, or the concepts presented, like please let us know. If you disagree with us, also let us know. We'd love to hear about that. You can find us on LinkedIn, and thank you very much.
Thanks, everyone.
Thanks a lot, David and Corey, for such a great presentation and answering all the questions in detailed manner. We will now be concluding the session. Would you like to say a few words before that?
I would just say we got some great questions in there, had really good attendees. So thank you for taking time out of your day. Thank you for asking us questions. We know that you'll have day jobs that you're tackling, so it means a lot to us to spend the time here with us.
Yep, and I just echo David's thanks for your time. And again, please don't hesitate to reach out to us through whatever means you can contact us. So thanks.